Have you ever looked at a supercar and just wondered, how do they get it to slice through the air so perfectly? Or how can a life-saving heart valve be designed and perfected before it's ever implanted in a human being? Well, the answer lies in a really incredible technology that lets us see the invisible. So, what's the hidden connection between a screaming Formula One car, a piece of life-saving medical tech, and the jaw-dropping special effects in your favorite movies? It all comes down to something called Computational Fluid Dynamics, or CFD. And believe me, it's a tool that lets us simulate, predict, and ultimately master the unseen forces that are all around us. You know, for most of human history, designers and engineers faced this huge problem. How in the world do you build something that has to move through forces you can't even see? We're talking about things like aerodynamic drag on a car, or the chaotic, turbulent flow of water around a ship. The old way of doing things was, well, it was brutal. You had to build a physical prototype, test it in a massive wind tunnel or a water tank, see if it worked, and if it didn't, you had to go back to the drawing board and start all over. This cycle was incredibly slow, insanely expensive, and a lot of the time, you only got a vague idea of what was actually going wrong. I mean, the difference between the old way and the new way is just night and day. Physical prototypes, you're talking about huge costs, agonizingly long timelines, and honestly, you only get a surface-level view of the physics. But CFD, it just flips the script. We're talking low-cost virtual tests, lightning-fast design changes, and a level of detail that physical testing could only ever dream of.
So, this brings us to the game changer itself. How did we make that incredible leap from clunky physical models to these elegant digital solutions? Well, we entered the era of the CFD revolution.
So what is CFD, really? At its heart, it's about using powerful computers to solve the fundamental math that governs how fluids, like air, water, you name it, actually move. It lets us simulate and predict with incredible accuracy how a fluid will behave in pretty much any situation you can think of.
The best way to think about it is like this. It's like having a virtual wind tunnel living right inside your computer. Instead of building one single expensive physical car, you can test thousands of different designs. You can change conditions with a click, run endless experiments, all without ever touching a wrench. It's truly limitless.
Now, it might sound like magic, right? But how does a computer actually see the flow of air over a wing? Let's quickly break down how we turn physics into pixels.
It pretty much boils down to 4 key steps. First, you create a 3D digital model of your object, the car, the plane, the whole shebang. Second, you generate something called a mesh, which basically breaks the space around the model into millions of tiny little cells. Third, the computer gets to work solving the complex physics equations for every single one of those cells. And finally, and this is the cool part, it visualizes all that data, turning a storm of numbers into a clear, beautiful picture of the fluid in motion.
And here's the secret sauce, this idea of discretization. Think about a digital photo. The more pixels you have, the sharper and more detailed the image is, right? Well, it's the exact same idea in CFD. The more cells you have in your mesh, the more accurate and realistic your simulation of the fluid flow is going to be. Okay, so running these intense calculations across millions, sometimes billions of cells requires an incredible amount of computing power. And this is where modern hardware, especially GPUs, completely change the game. A normal CPU kind of works on problems one after another, but a GPU, it's like an army performing thousands of calculations at the exact same time. This parallel processing power is what lets us run these massive simulations in a fraction of the time it used to take.
And the real-world impact? Oh, it's huge. Just look at this. By using these accelerated CFD methods, Volkswagen was able to cut their vehicle development time by a staggering 25%. That's getting better, safer, more efficient cars on the road, months, maybe even years, faster than ever before.
But the power of this virtual testing isn't just for one industry. No way. CFD is fundamentally changing how we design pretty much everything that moves through air or water.
In the automotive and aerospace worlds, it is everywhere. Engineers use it to sculpt the body of a car, to minimize drag and boost fuel economy. It's used to design more efficient aircraft wings. They even use it to peer inside a running engine to perfect the combustion process and get cleaner power.
But this is where it gets really profound. In the biomedical field, we're talking about applications that are literally changing lives. Doctors can simulate blood flow through a specific patient's artery to design a custom stent. They can perfect a heart valve before it's ever made. And in energy, it's used to optimize the shape of wind turbine blades to squeeze every last bit of power from the breeze.
And CFD shapes our daily lives in ways you'd never expect. It's used to design the HVAC system that keeps your building comfortable. It can model how pollution might spread in a city. And, it's the magic behind those unbelievably realistic fire, smoke, and water effects you see in the biggest blockbuster movies.
So, as powerful as CFD already is, it's on the verge of another gigantic leap forward. And it's all thanks to a technology that, let's be honest, is changing everything: artificial intelligence.
Okay, check this out. Instead of running a massive, complex simulation from scratch every single time, engineers can now train an AI model on thousands of previous CFD results. The AI essentially learns the underlying physics, and then it can predict the fluid flow almost instantly, turning hours of computation into just seconds.
And this isn't science fiction, it's happening right now. Audi did this exact thing to optimize their car's aerodynamics. They trained an AI that slashed the time it took to analyze a design change from hours down to a few seconds. That means designers can get real-time feedback. It's incredible. And the future this is unlocking is, well, it's mind-bending. We're talking about AI that can automatically generate the most perfect, most efficient shape for a part all by itself. We're seeing the creation of digital twins, perfect virtual copies of real aircraft that can monitor performance and predict problems in real time. This is truly transformative stuff. So think about where we started, just trying to understand invisible forces through slow, expensive, physical guesswork. And now, we're on the verge of predicting those same forces almost instantly with AI. So the critical question isn't really how we can see the invisible anymore. It's, with this incredible new superpower, what monumental challenges are we going to solve next?